So we have a first prize auction game here that we're going to be solving. We're going to be solving part A, and the link is in the description. So if you want, you can go ahead and try to solve it first, pause the video, and then come back. And now we're just going to go straight into it. So the first thing that we need to be aware of here, the question is that we are asked to assume that both bidders use linear strategies, which means that we have a bid which is dependent on the value, and then we have the linear strategy, which is AI times VI, where the I is either player 1, player 2, because we have two bidders for this one here. So essentially we're looking for some kind of strategy which says that if we look at for player 1, that his strategy will be his evaluation times some factor here. And this factor is what we're going to be finding. So this is essentially the question. What is A1? And what he wants is that he wants to profit maximize. So he wants to maximize his expected profits. Both of our players are drawing from a uniform distribution, which is between 0 and 1. And since both of them are drawing from the same one, and both of them are using this kind of form of linear equations, a linear bidding strategy, we also have that both of their strategies are going to be exactly the same, which means we have symmetry. So that means that we have that A1 will be equal to A2. And we can use this now to only solve for one of them. So we're going to choose to solve for A1. So we're looking for this kind of strategy right here. And now we want to try and find out how to maximize the expected profits. So we'll write up that we're looking for the expected profit. And it's for player 1. And we're looking for that given the draw. So this one here is his evaluation. And it can be between 0 and 1 given our uniform strategy. And then it's dependent on the bid, which again is also dependent on the evaluation, but is a function of it. So it's not necessarily exactly the same as the evaluation. And then we're just going to write up what this is. So for this, we have the profit, which is the difference between how he evaluates the object and how much he bids. Because if he wins it, he's going to be paying his own bid. So this is a first price auction, which means that when we have bid 1 and bid 2, if bid 1 is bigger than bid 2, then bid 1 wins and has to pay bid 1. That is a first price auction. So he's going to be paying if he wins his own bid, and then the difference between that and his evaluation is going to be the profit given that he wins. And then you have to multiply that by the chance that he wins. And we'll just, yeah, this one here is not necessary, but we can just write it up like this. And then one way to do it is to simply just say, okay, just gonna, in the beginning, write up that he wins given his bid. And this right here is our formula. And now we need to set up some, now we need to expand on his chance of winning. So we have that right now we can already see that his evaluation should be larger than his bid. So right now we can already assume that A1 is less than 1. And of course we're going to be getting an exact value for A1, so it might be kind of you might feel that it's unnecessary to even make assumptions about A1 right away. But for me, this essentially, and you could say less than or equal to, this just means that we're talking about some kind of bid shading, which basically means that he is going to be bidding less than his true evaluation. He's not going to be bidding his true evaluation. He's not going to be betting more. He's going to be betting less. So he's going to take his evaluation, which might be, let's say it's a half, and then he's going to shade that a little bit. So he's going to lower it just a little bit in order to try and make a profit in case he wins. All right. So now back to this. We're going to expand a little bit of 100 now. So this one right here is just going to stay the same. And now we're going to expand on the chance of winning. So the chance of winning is the chance that bid 1 is bigger than bid 2, and we actually don't need this conditional right now because it's already incorporated in that we have bid 1 right here. So we can just go ahead and do this. All right. So now we have the chance that bid 1 is bigger than bid 2. This means that the person bidding will win, and then they're going to be making the profit right here. So let's say that this right here turns out to be 50%, so he has a 50% chance of winning, and his profit is going to be a third. Then in that scenario, there will be a third times a half, which would then be 1/6. So then his expected profit would be 1/6. Okay, but we cannot calculate it yet. We need to get a form where we'll be able to maximize this formula. So we need to keep expanding on it for just a little bit more. So what we're going to do now is that we're going to assume that the bidder behind bid 2 uses a linear strategy. And we can do that because we've been given exactly this assumption. So we have been asked over here to assume that both players use linear strategies. So now we're just going to insert this strategy. So I'm just going to say this is the chance that bit 1 is bigger than, and then we have the evaluation here for the opponent bidder, and then multiplied by his factor and his rate of bit shading. So his evaluation times some value lower than 1. So now we actually have enough to try and get rid of this probability. So when we're trying to maximize it, we'd rather not have a probability in it. So we'd rather be able to calculate what this probability is. And now we're going to use some very nice formulas for calculating exactly that when it comes to uniform distributions. So in this case, we have one of the essentially best uniform distributions to work with, which is that we have actually, hold on for a second. I am going to put this down the bottom so that we can continue that later. So, what? Okay. Yeah, something went wrong there. All right. Just going to make a line here. Hopefully we'll have enough space. Anyways, so now we're just going to see a little bit about this distribution right here. So this distribution is a uniform distribution between 0 and 1, and it's one of those that are very, very easy to work with. But since a lot of the time you'll be working with distributions that are different than from 0 to 1, and the 0 to 1 is so easy to use compared to some of the others, we're just going to generalize it right now. So we're going to say from A to B instead. And now that we've done this, we're now going to try and find out what how you're going to calculate the probabilities. So now we're just going to take a probability of some value x being larger than a draw from this one right here. So we're going to say that this one here is going to use a y. So now that we have this, we are going to try and find out the probability here. And in this, it kind of helps if we're going to just think about the uniform distribution as being an actual kind of space where all of the values are. So start out with A down here, and you go all the way over to B here. And then we have all of these different values. And they're continuous. So it can be anything in here. And now we're going to plot down a value. And this is going to be x. So now where y is drawn from this between A and B, and y has an equal chance, that's the definition of the uniform distribution, y has an equal chance of being drawn anywhere along this distribution here. And if it's drawn anywhere here, so like for this one here, then y is going to be less than x, and anything over here. Then we have that y, going to be larger than x. So, and this one is the one we're interested in. So this, what we're essentially trying to find out is what is the distance between A and X compared to the distance between A and B. And that's exactly what we're going to be doing, not what we're going to be doing now. So we're just going to say this is equal to, and then we're going to take the distance between A and X. So we have X minus A, and going to divide this. Oh, I'm running out of space. So we're just going to put it over here, X minus A, and we're going to divide this by B minus A. And that is it. So all you're looking for is what is the relative distance from A to X compared to the distance of the entire distribution from A to B. And that is why we get this formula right here for the probability. So now we're going to be using this up here. So we're going to say that we have the evaluation here, B1 minus B1. And then we're going to be using what we have right here. So we have our draw here, B1, and we're just going to move over our V2, our A2. We're just going to be moving it over to the other side so that we have a pure uniform distribution, just to make it a little bit more simple. So our X in this case is going to be B1 divided by A2. So we have B1 divided by A2. And then we're going to minus it by our A, which in this case is 0. And we're going to divide it by B minus A, 1 minus 0. And this right here is then equal to B1 minus B1. And all of this right here just change in to this. All right. So now we have something that we can actually maximize. And we're going to maximize it with respect to B1 because that is the value that we're trying to manipulate so that we'll be able to get the most out of our profit. So now that we've done this, we're going to maximize it. And when we do this, we're just going to, well, we'll start out by multiplying this together. So we'll have these two right here. And then we're going to differentiate this. And yeah, now we're just going to be doing it just a little bit quickly here, because this part right here is pretty trivial. So now we're just going to be differentiating it right away. So I am going to be missing some notation here, but hopefully you guys will be able to follow what is going on anyways. So now we're differentiating this and maximizing it by setting this equal to 0. And remembering this right here. And this means now that we have the bit which is equal to value here, the valuation, divided by the 2 from over here. And if you want to write this in a way where A becomes very apparent, we can do it like this. So V1 is multiplied by half, and this right here is our A1, our linear strategy that we wanted to find. And this means that A1 is equal to A2, which is equal to half. And yeah, there are 2 ways to write a half in. All right, so hopefully this gave you an insight into how to solve this kind of problem.